Hello, my dear students. Welcome to mathematics classes for 9th standard. We are doing chapter number 8, quadrilaterals, and today your Jerry sir will explain the exercise 8.1 from question number 9 to question number 12 to you. So let's start the video. So we are doing question number 9 of exercise 8.1, and it says that in a parallelogram ABCD 2 points P and Q, as you can see here, ABCD is a parallelogram in which 2 points P, this one, and this point Q are taken on this diagonal BD, okay, such that this DP, this one from here to here, DP is equals to BQ, this one, okay. Now we have to prove that first part, triangle APD, AP and D, this APD, upper part APD should congruent to which one? CQB, it means this part, okay. In first part we have to prove this one. Then second part we have to prove that this AP is equals to CQ. See, if we prove the first part that these two triangles are congruent, so easily we can say that this AP is equal to CQ by CBCT only, the second part. Same thing, then they're talking about triangle AQB is congruent to triangle CPD. AQB, it means this one triangle, this one is congruent to triangle CPD, it means this one. Now if we prove these two triangles are congruent, so we can see that AQ equals to CP by what? CPCT. And then at last we have to prove that APCQ is a parallelogram. So let's solve this question. So as you can see here, I have already drawn this figure and I have written the given information and what we have to prove. I have already written that, okay. So now let's start the proof. So first part we have to prove that triangle APD is congruent to triangle CQB. So let's take these triangles only. So in triangle APD, it means APD and triangle CQB, okay, angle ADP, it means we're talking about this angle ADP, this triangle, this angle ADP is equals to angle CBQ, it means we're talking about this angle. We are saying these two angles are equal. Why? Because they are making what? Pair of alternate angles, because this BC and this AD are parallel. See, AD and BC are parallel, AD and BC are parallel, and this line is working as a transversal. So this and this angle will be equal as alternate interior angles. So by this we have said that these two angles are equal, okay. Now these two angles are equal, so we can say that AD is equals to CB. So AD is equals to CB. Why? Because it is given that ABCD is a parallelogram, and parallelogram opposite sides are equal. So opposite sides of parallelogram ABCD. And last we said that DP is equals to BQ, as it was already given in the question only, as you can see here, already given in the question. So we have written given. Now as you can see, we have taken two sides and one angle, and that one angle is also included angle. So by SAS rule, these two triangles are congruent. So here we have proved our first part. Now in second part we have to prove that this AP is equals to CQ. Now if you check the AP and CQ, so AP is the part of triangle APD and CQ is the part of triangle CQB, which we have already proved that these two triangles are congruent. So therefore these two sides are also equal by CPCT, corresponding parts of congruent triangles. Now we have to prove that in triangle AQB, it means this triangle is equals to triangle CPD, it means this one CPD. This sides triangle, left hand side and right hand side triangles are congruent. And then we have to prove in fourth part AQ equals to CP. So if we prove this part, so definitely we can say this is also equal by CP. So let's prove third part. So triangle AQP, AQ and B. So we have taken triangle AQB and triangle CPD, and then we are saying angle ABQ is equals to angle CDP. Now just check where it is, angle ABQ. ABQ, it means we are talking about this angle ABQ, this one, okay, this one. ABQ is equals to CDP. CDP, it means we're talking about this angle, these two. Same thing as we have proved here, this like this we have proved that these are alternate angles. In the same way, these two angles are also what? Alternate interior angle, as AB is parallel to CD. This one, AB is parallel to CD. So here this one is working as a transversal, this and this will work as a what? You can say what? Alternate interior angles. So this is also what? Alternate interior angles, and hence these are equal. Now we are saying AB equal to CD because these are the opposite sides of a parallelogram ABCD, and BQ equals to DP as it was already given here. BQ equals to DP. Okay. So by SAS, again SAS, these two triangles are congruent. And if these two triangles are congruent, so in fourth part we can say that AQ equals to CP by CPCT. So here we have proved our 4 parts. Now last part says that we have to prove that APCQ, which is coming inside this ABCD. This inside one figure is what? Parallelogram. So we know that in a parallelogram we need to prove that the opposite sides are equal and parallel. So let's prove it. So from the result first and second and fourth, the second what we have proved, we said AP equals to CQ. Where is AP? AP. We are saying AP is equal to CQ, already we have proved. Then in fourth part, we have said that AQ equals to CP. AQ equals to CP means AQ equals to CP. So it means opposite sides are equal. And we know that this is a property of a parallelogram, that in parallelogram opposite sides are equal. So here opposite sides are equal. So we can say that yes, APQCQ is a parallelogram since opposite sides in our quadrilateral are equal. Even we can prove that these are parallel also by proving that the two triangles, this and this, are congruent. Okay. So in this way we have proved these all 4 or 5 parts of question number 9. So question number 9 is over. Now move to next question. Now next question, question number 10, which ABCD given, a parallelogram given, in which AP and CQ are perpendiculars from vertices A and from vertices C on this diagonal BD. Then we have to show that this triangle AP and this APB is congruent to triangle CQD. And if we prove these two triangles are congruent, so easily we can say AP equal to CQ. So it is a small question and easy question also. So you will do this question by yourself. Now move to next question, that is 11th question, in which this figure is given. Okay, so in triangle ABC and triangle DEF, AB is parallel to DE, and this BC, this side BC is equals to EF, and BC is parallel to EF. These are parallel also, equal also. In the same way, AB and DE also parallel and equal. Now we have to see that they have joined vertices A, B and C. As you can see here, they have joined together with the dotted lines, and then they have joined this C to F also. And now they are saying that prove that ABED is a parallelogram. We have to prove this one. Second part, BEFC, this one side one, this is also a parallelogram we have to prove. And after that we have to prove that this AD is parallel to CF, this one side one, and AD is equals to CF. Then we have to prove in fourth part that ACFD is a parallelogram. So if we prove third part, then automatically we can say fourth part we can prove. Then fifth part we have to prove that this AC is equals to DF, and at last we have to prove that triangle ABC, this triangle is congruent to this triangle DEF. So let's solve this question. So we have written all the things which are given in the question, and what we have to prove we have written in this way. So this is the pattern to solve the questions. Now we have to start our solutions in the form of proof. So as you can see the figure, first part we have to prove that quadrilateral ABED is a parallelogram. This is a quadrilateral of 4 sides, as you can see here. Now in this quadrilateral you can observe that AB is equals to what? DE, as it was already given in the question. Okay, so we have written AB is equals to DE, and AB is parallel also to DE. So if one pair of opposite sides are parallel and equal, so we can say easily that this ABED is a parallelogram. So it was very easy part. So we said that yes, ABD is a parallelogram, as one pair of this quadrilateral is what? Equal also and parallel also. Now if ABD is a parallelogram, so now we can move to the other part, that is second part, quadrilateral BEFC. Same thing we can apply here also, as it is already given that BC is equals to EF and BC is parallel to EF. So as you can see here, BEFC, where BC is equals to EF and BC is parallel also given to EF, already given. Okay, here already given. So in this way we can say that yes, BEFC is also a parallelogram. Opposite sides of quadrilaterals are parallel and equal. So our second part also done. Now move to third part, which says that we have to prove that AD is parallel to CF. AD is parallel to CF and AD is equals to CF. AD, in the figure you can see, AD is parallel to CF we have to prove, and they are equal also. Now as we have already said that ABED is a parallelogram. ABED, in first part we said ABED is a parallelogram. Therefore AD is equals to BE. AD is equals to BE. E. AD is equals to BE because it is a parallelogram. Already we have proved in first part. And AD is also parallel to BE. This is our equation first. As you can see here, equation first. Now second we are saying that BEFC also parallelogram. Just we have proved in second part. So we can say their corresponding parts BE and CF are equal and parallel. They are opposite sides. So from equation 1 and 2 we can say that, as we said, AD equals to BE and BE is equals to CF. So BE common, what left? AD and CF. So AD equals to CF and AD is also what? Parallel to CF because AD was parallel to BE and BE was parallel to CF. So again here common cut, AD is parallel to CF. So opposite sides equal and parallel. So in this way we have proved our third part also. Move to fourth part where we have to prove that quadrilateral ACFD is a parallelogram. So in quadrilateral ACFD, AD is equals to CF and AD is also parallel to CF. Just we have proved in our third part. Just you can see here, equal and parallel. Therefore it is a parallelogram. And if it is a parallelogram, so we can say that AC is equals to DF. These are the opposite sides of this parallelogram. So in this way we have done till fifth part. Now sixth part, they are saying that prove that triangle ABC is congruent to triangle DEF. This triangle is congruent to this triangle. So what we are doing, just check here. In triangle ABC and triangle DEF, AB equals to DE, it was already given. Then BC is equal to EF, already given. And just we have seen that AC is equals to DF. As these are the opposite sides of triangle ACFD, just we have proved above side that ACFD is a parallelogram. So AC equals to DF because these are the opposite sides of this parallelogram. So in this way, side by triple S rule, triangle ABC is congruent to triangle DEF. So in this way we have proved all the parts of question number 11. Okay, I hope it is clear to you. Now let's see the last question of this exercise 8.1, where it is saying that ABCD is a trapezium. ABCD, it is a trapezium where AB is parallel to CD and this AD, this side, is equals to BC. Okay, it is given already in the question. Now they are saying that prove that this angle A is equals to angle B. We have to prove it. And then we have to prove that this angle C is also equals to angle D. Okay, and at last we have to prove that the triangle A, B and C, it means we have to join this one afterwards, this line A to C. This triangle is equals to congruent to triangle BAD. It means we have to join this also. We have to join this diagonals. Okay, so we have to prove this one. And at fourth part we have to prove that diagonal AC, this diagonal is equals to diagonal BD. Okay, so these things we have to prove in the question, and they have given hint also. We will utilize this hint also. Let's solve this question. So we have written all the things which are given in the question, and what we have to prove we have written already here. And what are the things given? We have already shown in the figure that AD is equals to BC. Now one hint was given, so we will utilize that hint. So we will use as a construction because we have to use as a construction. So because it is given that ABCD is a figure, so extend AB, we have extend AB as it is given in the book only. Extend AB from B to E point in such a way that this this C is parallel to AD. See, AD is parallel to CE. Okay, in this way we have extend, and intersecting AB produced at E, which is intersecting this AB. When we have produced, it is intersecting this line at point E. Now AECD is a parallelogram. AECD is a parallelogram. It means AD is parallel to EC and AD is equals to EC. In this way we have done our construction that AECD is a parallelogram. Now first part we will prove that, which we have to prove that angle A equals to angle B. So let's solve this part. So first we are saying that AD equals to CE. Just pay attention here. AD is equals to CE. AD is equals to CE, as these are the opposite sides of a parallelogram. AECD, just we have said earlier, with the help of construction. So we can say these are equal. But it was given in the question that AD is equals to BC. It was given in the question. So AD common. What left? CE and BC. So CE and BC are equal with these two. Okay. Now we are saying that angle CEB. Angle CEB is equals to angle CBE. Just check here. CEB, it means this angle. We are saying equals to angle CBE. It means this angle. Why these two angles are equal? Now if you remember the property of triangle, we have learned chapter triangle, chapter number 7, that the angles which are opposite to equal sides are also equal. What we have learned? angle opposite to equal sides of a triangles are also equal. So it means that just we said that BC equals to CE. Where is BC? BC equals to CE. It means these are equal sides. So angles opposite to equal sides are also equal. So it means this angle and this angle will be also equal. That's why we have written that angle CEB is equals to angle CBE. Now, if we observe the figure properly, then we will found that AD is parallel to CE. AD is parallel to CE because already we said that AECD is a parallelogram, and if AD and CE is parallel lines, so AE is working as a transversal. So if these AE is working as transversal, so we can say that angle A plus angle CEB, or you can CEA, same thing. These two angles will make how much? 180 degree angle. Their sum will be 180 degree angle because these are the angles which are made on the same side of the transversal. So angle A plus angle CEB, or you can say in place of CEB what we can write? We can write angle CBE, just we have proved that CEB is equals to CBE. So we have written CBE equals to 180 degree. Okay, this is our equation first. However, angle B plus angle CBE, just check where is angle B and CBE. Angle B and angle CBE, it means this plus this angle, what they are making? They are making linear pair. What they are making? Linear pair. Angle B and angle CBE, these two angles are making linear pair. So angle B plus angle CBE also is equals to 180 degree, as they are making linear pair. So this is our equation number 2. Now, right side 180, right side 180, both are 180 degree. So we can say angle A plus angle CBE equals to angle B plus angle CBE. But here this again one common thing, so we can cut from this. So what left? Angle A and angle B. 180 we can cut from 180, angle CBE we can cut from CBE. So what left? Angle A and angle B. So angle A equals to angle B from equation number 1 and 2. And here we have completed our part 1. That is, we have to prove that angle A equals to angle B. Now we will move to second part where we have to prove that angle C is equals to angle D. Now in second part we have to prove that this angle C is equals to angle D. This angle, these two angles are equal, we have to prove. So just check here. We said that AB is parallel to CD and it was already given in the question. Therefore angle A plus angle D equals to 180 degree because AB is parallel to CD, okay, and this AD is working at transversal. So this and this angle will, how much it will make? 180 degree angle, because they are the angles which are made on the same side of the transversal AD. Okay, so angle A plus angle D equals to how much? 180 degree. But it is already written that AB is parallel to CD. AB is parallel to CD. Therefore, BC will also work as a transversal, no? Okay, so angle B and angle C will also make how much? 180 degree angle, because these are also same like angle A and angle D. So these are also making what? Angles on the same side of the transversal, but this time transversal is BC. Okay, so angle C plus angle B is also how much? 180 degree. Now again see, 180 degree also, here also 180 degree. So from this and this we can say that angle A plus angle D is equals to angle C plus angle B. As we have written here, 180, 180 we can cut. So angle A plus angle D equals to angle C plus angle B. Okay. Now in our first part we have proved that angle A is equals to angle B. So we can replace the value of angle B with angle A, as these both are equal. So in place of angle B I am going to write angle A here. Okay. So angle A, angle A, angle D equals to angle C, angle C. In place of angle B what I have written? Angle A. Now from angle A we can cut our angle A. So what left? Angle D plus angle C. Or we can say angle C equals to angle D, which we have to prove. So second part also we have proved here. Now in third part we have to prove that triangle ABC, this one triangle, this triangle, okay, upper right hand side, okay, this triangle we have to prove is congruent to triangle, what? Triangle BAD. BAD, it means this triangle, okay, it means AB is common side here. So we have to prove these two triangles, this and this triangle, are congruent. So let's prove it. So in triangle ABC and triangle BAD, as you can see here, in triangle ABC and triangle BAD, we have taken BC equals to AD. BC equals to AD. Okay, as it was already given in the question. Okay, these two sides are what? Equal, side of trapezium. Then AB is coming in this triangle also, ABC, and AB side is coming in triangle ABD also. So it is a common side. And then we have proved that angle A is equals to B, or you can say angle B equals to angle A, just we have proved above. Okay, so we can say yes, angle B equals to angle A, because angle B is coming in this triangle ABC, and angle A is coming in triangle ABD. So these two angles are equal. So one angle, two sides. It means this is the included side only. So included angle only. So by SAS rule, side rule, we can say that triangle ABC is congruent to triangle BAD. So our third part is also proved. Now in fourth part we have to prove this diagonal dotted line. AC diagonal is equals to BD diagonal. Okay. Now just we have proved that these two triangles are congruent, triangle ABC and triangle BAD, and AC and BD are the corresponding sides of these two triangles only. Therefore, these two sides AC and BD, which are diagonals also, are equal by CPCT, corresponding parts of congruent triangles. In this way, we have finished our exercise 8.1 of chapter number 8, that is quadrilateral. I hope it is clear to you. At last, I just want to say be safe and God bless you all.